All right, so we're working with this problem where we've got sodium hydroxide and sulfuric acid. Our balanced chemical reaction is, just a second, is H2SO4 plus 2NaOH yields 2H2O plus Na2SO4. Okay. Now we used our, well, when we look at our two solutions, we've got a sodium hydroxide solution where we've got 35.7 milliliters and 0.7 molar. We've got 42.9 milliliters of H2SO4 with a 0.7 or 0.5 molar solution or concentration. Now the question of this is, well, which one was the limiting reactant? And we already determined that our limiting reactant was indeed our sodium hydroxide. Okay, so we wrote LR above that. Now, whenever we identify, so when we identify our limiting reactant, and we know that the total number of moles of sodium hydroxide are 0.0357 times 0.7. That gives us a number of moles of 0.02499. Now for H2SO4, we have 0.0429 times 0.5, which gives us 0.02145 moles H2SO4, and then this one is moles NaOH. Okay, now what we need to do is we need to figure out, and our goal for this question is to figure out what is the final hydrogen ion concentration. So we say 0.02499 moles of NaOH, 1 mole NaOH. And what we're trying to do is we're trying to figure out the number of moles of hydrogen ion that are actually utilized. Okay, so 2 moles, or sorry, that's 1 mole. What we're doing here is relating the components of our balanced chemical reaction to one another. So I need to change this to 2 moles of sodium hydroxide for 1 mole of H2SO4. Okay, now what we need to narrow in on is what is the number of moles of our hydrogen ion that are actually utilized, or that are actually, that are going to be consumed. So what we've got is for every 1 mole of H2SO4, there are 2 moles of H plus. Oopsies, not that. There are 2 moles of H plus. Okay, so what this means is that we have 0.02499 moles of H plus that are going to be needed. Now, this seems a little bit weird, and this is one of the reasons that I got tripped up whenever I was doing this calculation during our normal meeting time, because I was like, wait a minute, no, and so I just kind of got frustrated. 0.02499 moles of sodium hydroxide are going to need 0.02499 moles of hydrogen ions. Okay, now we only have 0.02145 moles of H2SO4, but let's dig into this a little bit further. Let's find out the total number of moles of hydrogen ions. 0.02145 moles of H2SO4. 1 mole of H2SO4 has 2 moles of H plus. So what is our, I'm going to erase that. Total number of moles of H plus? Well, it's 2 times 0.02145. And that's going to be 0.0429 moles of H plus. So what we need to do is we need to reflect on the first part of our calculation, which was the total number of hydrogen ions that are used by all of the hydroxide ions. So what we're going to do with that is we're going to subtract 0.02499 moles of H plus. Okay, so 0.0429 minus 0.02499. The difference here, 0.01791 moles of H plus, this is the number of hydrogen ions that are left over after all of our hydroxide ions have taken up as many hydrogen ions as they can. So we have 0.0179 moles of hydrogen ions. Now the question was, what is the final hydrogen ion concentration? That's going to be moles divided by liters. If you remember, the total volume was 79 milliliters, or 0.079 liters. So I'm going to say 0.01791 divided by 0.079, and that's going to be 0.01791 divided by 0.079 equals 0.22. I'm going to call that 0.227. So that's going to be the final concentration of our hydrogen ions that are in this solution after it's all said and done. All right. I hope that was helpful. This is a little bit of a tricky question. It's a challenging question because you have to figure out what was there and subtract from, well, what was used. And then ultimately what's left over will give you what you're looking for. All right, everybody. Oh, and actually before I go, molar. All right, everybody. I hope you have a great afternoon and have a good one.